Hello, my name is Jake. I'm representing Software Engineering Team 9, and this is our project Humidibot. Now, in life, we're progressing rapidly towards an age of optimization. We have solutions to optimize all sorts of aspects of our life, from home security to the food we eat to the amount of exercise we do. We have ways of tracking and maintaining proper levels for all of these parameters that affect our everyday health. But one thing that's gone almost ignored is the quality of the air we're breathing. How do we know that the air we're breathing has the right level of humidity? And hopefully you see where our project comes in. Now, it's not just our personal health that is a factor, it's also the health of other things living in our homes, including plants. And even the electronic devices in our house are somewhat humidity dependent. And even though it plays such a role, the ability to track humidity in your own home typically isn't there. The average homeowner does not own a device to measure the relative humidity of their surroundings. Too little humidity in the home can cause electronic equipment to malfunction and other health issues like dry throat and breathing problems. And too much humidity can create a breeding ground for bacteria and fungi. So if you have mold in your bathroom, this might be a culprit. People might have issues with the humidity levels in their home and not even realize it. They have these symptoms and they're not sure about the cause of the problem. Enter Humidibot. Humidibot is a system that monitors the environment for temperature and humidity in real time. So a user can set up multiple environments on our web app called rooms. They could just be actual rooms in your home. They might not be. It depends on your use case. Usually they will be, though. And you'll be able to get readings within each of these rooms and keep track of them all around the house or the greenhouse if you're using this for plant keeping purposes. Now, and the average person probably has really no idea what level of humidity they're aiming for. So we offer our abilities to the user to specify parameters for each room and determine optimal temperature and humidity for that room. That'll take into account things like the number of plants there, the number of people living there, things like that. That will change what is optimal for that room. Now we have a residence mode and a greenhouse mode that you can set for each individual room, not just your whole entire account. That'll help also determine what the proper level of humidity is. Our model is cloud-based, so all the data will be stored and you'll be able to access it on the go from a web application. With Humidibot, we're aiming to be a flexible tool that users can use to monitor and control the relative humidity of the environment for plants and family. Each user will be able to save data associated with their home or greenhouse, the number of doors and windows in the room. Perhaps there is a family member with a condition that makes them humidity sensitive. You'll be able to account for that in the app. And of course, the number and type or arrangement of plants in a greenhouse or residence will also factor into optimal humidity settings. The system will recommend a plan of action in order to satisfy these needs. And this will appeal greatly to anyone looking for an easy way to keep track of their plants' needs. Perhaps if they're new to the greenhouse scene, this will help them a lot. But even veterans will probably have a much easier time keeping track of humidity levels using Humidibot. And we want to supply our users with the tools needed to automate this altogether. The hardware requirements are very lax for this. So of course at the crux of things you have the DHT22 temperature and humidity sensor. You have a Wi-Fi module since this is all going to be working wirelessly, a power source, and a breadboard, as well as a 10K resistor and cables just to connect things together and to make sure that the signals are going to the right places, things like that. So in our current state, we have the ability to read temperature and humidity data in real time and update a Google Firebase with the latest readings. We have a dashboard UI where you can see rooms associated with a user account. We have a fully fledged login UI with the ability to register or recover a lost password. Now, of course, we don't have everything finished yet. Some features we're planning on adding are the ability to add, change, and delete rooms. In this iteration, we we didn't really have the means to demonstrate that, as we needed multiple setups in order to do that, and we currently don't have the hardware. Lack of hardware is something we're looking to resolve by the time of the next demonstration. We want to have a refined algorithm layer to determine a plan of action, giving the room's parameters. Again, that's a big thing with a system that's supposed to be automatic and make recommendations based off that data. Right now, our implementation of that is very slim, so we're looking to develop that a lot more. And lastly, we're going to implement a discussion forum for users to discuss perhaps any tech issues they have, and maybe other users can help them resolve it, or just curious about what other people in the Humidibot community are up to. Having a forum will be a great way to connect with our users. So this is just an overview of the project as a whole, but now we're going to move on to where we're going to demonstrate what we have already in action. Okay, so real quick, I'm just going to show you. Right now we have 2 users. So here's our Humidibot sign-in page. I'm going to right now register for an account. So my email address, SiriJake99@gmail.com. If you have any questions about the project, of course, you can use that email address to contact me. I'm just going to type in a password. I'm not going to say what it is, of course. And click the register button, and bam, here we are. So if we refresh, you can see this third account that was just registered. That's mine. So I'm going to just sign in with the account I just made. Submit, and congratulations, we're signed in. So as you can see, there are 2 modes, residence and greenhouse. I sort of glossed over this during the intro, but essentially these modes will determine what options you have available to you. Greenhouse mode sort of activates some more advanced features. However, right now it is only changing the color. Of course, that will be fixed eventually. Here we have a sign out button in case you want to sign out. Let me just sign right back in. All right. Now, right down here, UI is a little bit messy in its current state, but you'll see humidity is set to X% and the temperature is X degrees. These are placeholders. So as of right now, we don't have any actual hardware connected to this account. So what I'm actually going to do is I'm going to access the database and change the values. So my user ID would have to be this one. So this latest humidity, we're going to change it from X to an actual number. Let's just go 420. This, of course, doesn't really mean anything. We're just using some numbers. Latest temp, we're going to change to 69 degrees. Okay, so this has changed the information in our database. In the actual final product, these changes will come about once every 2 seconds from the sensor that is connected to the Wi-Fi module that is connected to the database. I'm going to show that off at the end of everything here. But if we go back, we can see immediately our changes show up. We have 420% humidity, 69 degrees temperature. We may decide to implement both Celsius and degrees Fahrenheit. Perhaps even Kelvin if the demand is there. But for now, here's what we have. All right, so we can toy around with this residence greenhouse mode. But if we refresh the page, we'll see that, yes, indeed, they are updated with the current database values. And that's what's going to be updated from the Wi-Fi module. As it stands right now, we currently only have support for 1 room. So unfortunately, changing the name of the room inside the database. Like, let's just do that right now. For instance, we'll call it Jake's bedroom. Sadly, will not reflect in the actual application. It just still says default room. But again, if we change the temperature and humidity amounts, like let's just change them to, for example, 71 and 418. Bam. Yeah, it updates in real time. You don't even have to refresh the page. So that's this app. Right now, it's definitely a work in progress, but as more features are implemented, it's going to look exponentially more impressive and useful. Now, let me talk a little bit about the back end. We're using Firebase as our database software, and it's pulling a lot of the legwork. We're using a Firebase Arduino library to communicate from the Wi-Fi module to the database, and the database itself is roughly what you would expect. We have a hierarchy here of current user. That's any user that's logged into the system right now. The list of users, the rooms that they have available. We also have a room count variable just to keep track of how many of those there are. Within each room, we have humidity data and temperature data and the name. And this goes for all the user accounts. So nothing too fancy, just a pretty simple user account system. Each user account stores the room data in the database. If you want to check it out, I will leave a link in the description to the app itself. You can make an account and register and play with what we have at the moment, if you would like. Okay, so here is a view of what's going on the hardware, and as you can see, it's pretty simplistic. So over here in the white, we have our actual sensor. Unfortunately, that isn't working at the moment, which is why our demonstration unfortunately couldn't actually use this sensor. But in the future, we're going to get more sensors, and we're going to definitely demonstrate that in part 2 instead of just using makeshift values. Over here in the blue wire, that is connected to power. And this white wire, which is connecting the sensor to the Wi-Fi module, that is just essentially transferring all the data. All the signal is going towards this node right here. Now this Wi-Fi module is going to transmit the signal to our database, and that is essentially how this is all going to work. The plan is to implement a much neater box type of packaging around this, sort of like you would see in an actual home device. This is a very early prototypical stage of this product, so it's not looking too fancy right now, but of course we're going to work on that moving forward. As you can see, it's pretty simplistic. Signal moves from sensor to Wi-Fi module. Wi-Fi module goes to the database, and once the data is on the database, users will be able to view it from their account page, as you would expect. Again, there aren't any real complications here. One thing you might have noticed, though, if you were paying close attention to the hardware slide during my introduction, is that I mentioned pull-up resistors that aren't on the breadboard at the moment. Those aren't actually vital to the functioning of the system. They're just for consistency's sake. They make sure that the hardware keeps running for longer, but they're not needed to get it working. So that's why at the moment they're not there. If these are ever mass produced, of course, they will have to have the resistors added. In fact, the breadboard will probably be a thing of the past as well. So, ladies and gentlemen, what you're looking at right now is Humidibot. If you have any questions about this, of course, there is the dedicated call we have, the 30-minute call. Will be available to answer any questions you might have about the project there. But overall, I think by now you get the picture. So Thank you all for listening, and I'm looking forward to demonstration 2, where we'll be showing off a much more complete and impressive product.